Hello everyone! In this video we're going to be looking at some real-world examples of parallel lines that are being cut by a transversal. I've pulled some problems from released SOLs for us to look at. Let's read through this first one. The table and legs are attached and create an angle that is 45 degrees. That's been marked for us. What must the measure that is marked X be in order to make the table parallel to the ground? Ultimately, we're trying to find this angle at the bottom. If the picture confused you, then maybe what's better to do is recreate it as a parallel set of lines and a transversal. The table and the ground with a transversal. This 45-degree angle is between the table and the transversal. And we're being asked to find X between the transversal and the ground. By eliminating this other leg of the picnic table, it may be easier to see what kind of relationship these two angles share. Both of these angles are on the inside of the parallel lines and on the left side of the transversal. These are known as consecutive interior angles. From our very first video, we've learned that consecutive interior angles have a supplementary relationship. Therefore, X plus 45 degrees equals 180 degrees. Solving for X, I would subtract 45 degrees, and X will equal 135 degrees. Looking back at our original picture, 135 degrees is a probable answer because this is an obtuse angle. Our second example reads, a diagonal walkway cuts through a park bordered by two parallel streets. The Parks Department plans to add an additional walkway as indicated by the dashed line segment in the figure. What is the value of X? Here's one street which should be parallel to the other street with the diagonal walkway. Again, the picture may be confusing. We could redraw it as a set of parallel lines and a transversal. This 132-degree angle between the street and the walkway would transfer here. They've also added in a dotted line that creates a right triangle. I'll be back to that in a minute. This 32-degree angle unlocks all other angles in this picture. I can use alternate interior angles. I can use corresponding angles. And I can use vertical angles to fill in 132 degrees in these four locations. I can also use linear pairs to find all other angle measures. 180 minus 132 is 48 degrees, so all missing angles are 48 degrees. To transfer that back into our picture, this 48 degrees between the diagonal and the street would be here. Now all my focus is going to move to this triangle. Using the triangle sum theorem, I know that the three angles within a triangle have to add up to 180 degrees. I have already used 48 degrees and 98 degrees, so whatever's left out of the 180 degrees will be the value of X. (180) minus the right angle minus 48 degrees leaves me with 42 degrees for angle X. Our last two problem-solving examples are not word problems. These problems require us to think algebraically. In the problem on the left, we have if line A is parallel to line B and the measure of angle 3 is 65 degrees, then what is the measure of angle 2? I'm going to go ahead and label my picture with all the 65s I can find. Angle 5 is vertical, so it's 65 degrees. Angle 7 is an alternate interior pair to angle 3, so it's 65 degrees. And angle 1 is corresponding to angle 3, so it's 65 degrees. Now, using linear pairs, I can find all the other missing angles. 180 minus 65 leaves me with 115 degrees. Now I can clearly see my answer. Angle 2 is 115 degrees. I could have gone about this a different way also. I could recognize angle 3 and angle 2 as a set of consecutive interior angles. We know that consecutive interior angles are supplementary. Calling the measure of angle 2x, I could set up a small algebraic equation and solve for x. X equals 125 degrees. In my very last example here, I'm working with all algebraic values. It says, if line P is parallel to line Q, what's the value of x? Here, I have no measurements pre-given to me, just algebraic expressions in the different angles. Knowing that line P is parallel to line Q, I should be able to find a set of angle relationships. This upper angle, labeled 4x, has an alternate interior pair that I could also label 4x. Then, if I use all three angles that create line Q as one giant supplementary set, I'll be able to solve for x. 4x plus 3x plus 2x combine to make 180 degrees. Add like terms together. 4x and 3x is 7x. 7x and 2x is 9x. Solving for x, I'll divide by 9 on both sides, which will leave me 20. Therefore, the value of x is 20 degrees. Thank you again for watching our video. I hope this helped you with your parallel lines and transversals. Happy studying!